Last video we dealt with interpolation, all right? And in this video we are going to deal with extrapolation. And so just to reiterate and not to spend a lot of time on it, maybe I should just go straight into extrapolation. When we extrapolate, and you'll see the interpolation here. When we extrapolate, we basically will have an x and a y, x, y, are horizontal and a vertical, and again we'll have 2 points, okay? And extrapolation is concerned more with what's happening outside. So if we have these points in between using interpolation, we can form ourselves a straight line. We don't even need the points inside. All we need are 2 points to form a straight line. And we can do that with y is equal to, can actually do it with m is equal to the rise, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where this is x sub 1, y sub 1, and we have x sub 2, y sub 2. And so, of course, we can just have y's equals to m times x sub 2 minus x sub 1. And so we get this particular equation, all right? And if x is just 0, we'll get this equation. Typically, we use the y is equal to mx plus b. So this equation, this form, is what we're looking for, okay? And we know that m is just the rise over the run. And we know that the b is the y-intercept. It's where this equation will hit the y-intersection. So if x is equal to 0, y will equal to b. Thus we have 0, b at that point. This is pretty much what we're going to use. When you have this equation, though, this equation will allow us to extrapolate, but it will also allow us to interpolate, okay? Which is awesome. So let's go back to Microsoft Excel. We're going to go to our extrapolation sheet here. It's just our template. And with this template, you'll see that, again, we still have our initial velocity template. We're going to put our data in there. It's going to help us predict our range. We're going to use our verification template. We know where our information is. We still have our interpolation template here. And then at the end, we have an extrapolation template, okay? And so all of these will produce graphs and equations of the line for us. So let's just go ahead and acquire that data first. And we want to put that data into this folder. We don't necessarily, we can pull it from interpolation, but we want to acquire our initial velocity data, and we want to copy that. We don't want to mess with our stuff. We don't want to mess with what's happening in that previous folder. In other words, let's just say we start manipulating the data over here. We don't want to do that. We want to keep it pristine. And so we're just going to duplicate this and then save it in that folder. And I'm going to go with copy 3. It's just letting you know how much we're using this data over and over and different things that you can actually do with it. So I'm going to say save. So that's one thing. And now I'll go and grab the other one, and that's verification. So I want to duplicate this. And I'm going to take our verification data, duplicate that, place this in our extrapolation folder, save. Now we have everything that we need to work with. So I'll just go back. I like to go through the folders, open, and then Dropbox, brass, physics, brass, Eric, extrapolation, and then this. So the first thing we want to do, let's just go ahead and copy our initial velocity data. So I'm just going to copy that, go back, and then go into the extrapolation, last name, first name. And we'll just paste that here. Okay, and of course we're getting the appropriate information here. And our prediction template is starting to populate. Let's go to our verification template, and we're going to go ahead and get our verification data. Just going to copy this. I'm going back into the initial velocity. Sorry about that. I'm going to have to get out of that and go back to the extrapolation. And let's paste that in A, and we'll see that our prediction template should come out fine. Now if we look at our interpolation template, all of our information is there. This is great. Okay, and our graph should be set. Yep, it is. I can make that bigger if I want to. And then let's go to our extrapolation. It's the same template. In this particular case, we're going to have a different graph. And this time we actually have an equation of the line. So we have our y equals to mx plus b. So we know when x is 0, when the angle in degrees is 0, our range is 39. It's 39 centimeters, approximately 40 centimeters. And that's what this equation is describing. So I can put in values all the way through here and come up with new values. Okay? So we'll just say, I'm going to say that that's it for this particular one. We'll probably use this in other areas. We could actually predict what's going to happen at 10 degrees, but I'm going to go ahead and stop there. If we do it, we'll do it in the classroom. I'm expecting you guys to have all of these tools. So let me just get out of this. And next, we'll talk about the alternative hypothesis.